problem on exponential growth and decay. Just a basic overview. Here's the standard general equation for exponential growth or decay, where y is the amount that you're going to have after x periods of time. A is going to be your initial value, and B is going to be your growth or decay factor. So whenever you're doing one of these problems, the first thing you want to write down is just y equals AB to the x. Kind of like when we're writing equations for lines, where you have y equals mx plus b, you just fill everything in and then you go ahead and use that equation to solve problems. So anytime we're doing a problem that asks for exponential growth or decay, we're going to be writing down this general formula right here, where y equals AB to the x. The first problem we're going to be doing right here is just talking about how to get B, which is the growth factor or the decay factor. Now, if it's a growth situation, you need to add 100% to the percentage that they give you in the problem, and that way you're actually growing. So in a growth situation, your B actually has to be greater than 1. So let's say that they tell us that we're growing by a percentage of 32%, then our growth factor is actually going to be 100% plus 32%. And that's actually going to give us 132%. Now, when we put that in the problem, we need to change it to a decimal, and you can do that by moving the decimal place 2 points. 1, 2 would give us a B equal to 1.32. If it's a decay situation, you have to take 100% and subtract off the amount that it's decaying. So, for example, if it's decaying at a rate of 40%, then we would take 100%, subtract off 40%, and we would have a decay factor, or what we'd be using in our problem, of 60%. And in that case, that's going to give us an answer, or I'm sorry, the decimal that we use in our problem of 0.6. For B. And anytime it's a decay situation, B is going to be between 1, so it's going to be less than 1, but greater than 0. So in this problem, we're actually going to be figuring out what the population of Colorado is, some years from when the problem was written. So the first thing we want to do is we want to write an exponential function to model their population. Well, if you read through the problem, this model was based on data that they had in 1980. And their initial population was 2.9 million, so that's going to be our A. Since then, the population has increased by about 1.7% per year. So the fact that it says increased means we're going to have a growth problem. So we might as well figure out B right here. Well, we know it's growth, so we're going to take our 1.7% and we're going to add on 100%. And that's going to give us a total percentage of 101.7%. And as a decimal, so we move that 2 places, so as a decimal, our B is going to be 1.017. Now again, here's our initial amount, so all we have to do is fill in y equals A, B to the x. So y equals A, which is 2.9 million, times B, 1.017 to the x power. Okay, and then right here where it says estimate the population of Colorado in 2010, well, we're estimating the population, so that means we're looking for y, because that's the amount after x period. So here's our original equation, 2.9 times 1.017 to the, now we're not going to put 2010 in because we're not looking for the population 2010 years from now. We're looking at it from 1980 to 2010, and that's 30 years. So on your calculator, if you type that in, you end up with an answer of about 4.8 million, and that's the key. It's not 4.8 people, it's 4.8 million people. So if it continues to grow at a rate of 1.7% per year, in 30 years from 1980, there should be about 4.8 million people. Now, the next part of this problem is a little bit more difficult. We're actually going to be figuring out when the population is 6 million people. So in this case, let's just write our equation again so we can look at it. So 2.9 times 1.017 to the x. Now this time they're giving us the population, so that's actually y. So we're actually going to be figuring out when y is 6 in this case. So that's a little bit more difficult because now we're solving for the exponent. There are two ways you can do this. You can actually guess and check. You can, put some values in for x and see when you get close to 6. Or, and my preferred method is actually using the graphing calculator. So if you turn your graphing calculator on and you hit the y equals button, we can go ahead and graph this equation, the right-hand side here. And then some people like to use the trace button, but I think it's a lot easier to use the table button. So here's our equation. Be careful, make sure you have the caret key to the x power. And there's our equation, it matches. Now we don't put the 6 in because that's y, and that would go here on the left-hand side of the equal sign. So we just put the right side in. You can go ahead and hit graph. And we're zoomed in very close, so we can't really see the exponential part of this function, but the only thing you need is to know right above the graph is a table button, and if you hit second and then table, now we have all of the x values and their corresponding y values. So just a minute ago, we said that in 30 years, so I know I got to go for a while here, in 30 years, there would be about 4.8 million people, and there it is. Okay, so we want to know when it's going to be 6 million. So now we're going to watch this side for 6, and then we're going to read off the corresponding x. And as you see right here, in about between 43 and 44 years, it hits 6 million people. So in this case, we'd be looking at an answer of 6 years. If you wanted to guess and check, I'm sorry, 44 years. If you wanted to guess and check, you could just type into your calculator 2.9 times 1.017 and then just guess an exponent. And we know it has to be bigger than 30 because 30 years gave us 4.8 million. So we'll just take a guess. We'll put 40 years. And we end up with an answer of 5.7 million. So you have to go higher than 40. So, and if you hit second, enter, it'll bring up the last thing you typed. You can go ahead and just edit that, and let's take a guess at 45. Now we know we're too high, so we have to sort of drop down a little bit. So again, the answer here is 44 years. It says when will that happen? So we know, well, the original was in 1980. Add 44 years to that. So in 2024, the population of Colorado will reach finally 6 million people.